This video will discuss the solution to question 24. Please consider the figure below. Assume OP1 and OP2 are ideal operational amplifiers. All diodes are ideal diodes that can be modeled as ideal open circuits for an anode voltage minus cathode voltage smaller than 0.7 volts and as ideal voltage sources with an anode voltage minus cathode voltage of 0.7 volts for any positive current flowing from the anode to the cathode. Assume R larger than 0, C larger than 0, Ra larger than 0 and Rb larger than 0. All components generate noise. If a stable oscillation is achieved, what is the approximate peak-to-peak value of Vc if only diodes D5 and D6 are used and the rest are removed? And then some options are given for the peak-to-peak voltage. Let's process the given information first. We know that D5 and D6 are kept in the circuit and all other diodes are removed. So let's get rid of them like this. So we know these two still exist. These two diodes are connected to the output of your frequency-dependent network. And we know that when the voltage here is 0.7 volts, these diodes will behave as ideal voltage sources. So it will never exceed 0.7 or, for the diode in the opposite direction, negative 0.7 volts. That means that we also know that the peak-to-peak voltage at this node will be 1.4 volts peak to peak. The next component through which the signal will travel is this operational amplifier, of which the output is directly connected to the input. That means that this is a unity gain buffer and the signal will simply be copied to VB. So nothing changes from VA to VB. And the last bit of information that we need is that this signal will travel through this inverting amplifier to reach VC, which is this node. In question 21, we found that this inverting amplifier needs to have a gain of -29 for the oscillator to sustain oscillations. That means that the peak-to-peak voltage at Vc would be 29 times larger than our 1.4 volts peak-to-peak at the output of our beta network. So the voltage at C, peak-to-peak, will be 29 times 1.4, and that is 40.6 volt peak-to-peak.